Hello and good afternoon, or hello and good morning, depending on where you are. We'd like to welcome you for the web demo news in KISSoft-Release 2019. This is me, Jürg Langhart, and my colleague Ilya Zikur. We are from technical sales in KISSsoft. Today we would like to present you the best features in the new KISSoft-Release. The new KISSoft-Release is out since last week, and you can get a test version of this release if you want so. You can also download it from our customer area. Also, we will have a user meeting in autumn, in October, where you can hear also news about the new features. And we also would like to give you the chance to give us questions during this web demo, and we will try to answer this at the end of this web demo. So I would like to start with the software, and first I would like to show you some points in handling. Software is also important, not from functional side, also from handling side, and always we have some improvements in handling, and again we also have in this release. In this release we have, for example, a new setting what you can use to have extended display for the toolbars. This means now you get a description on each of the icons, and this may be helpful. If you like this, then you can read and understand these icons immediately. Another new option in handling is, you can see in the new release we can have several graphs in parallel now. In the releases so far, it was only restricted number of graphs were allowed to be placed, and now you can see, for instance, for this cylindrical gear pair, I placed a graph for 3D geometry, also placed an graph for 2D geometry, and I placed a graph for Wörterline. So at the first glance, I can directly see what is about lifetime, what is about meshing, and what are the proportions on a 3D gear. So this is a nice possibility, and just because of this topic is quite current or quite actual also with our customers, I would like to show you something about placing the graphs. Maybe you also have the situation that if you move a graph somewhere within the software, it provides you the docking stations. So it may be that you may not want to have it docking stations provided, and therefore if you press Control in the same time as you move it, you can see now the software disables the option to have the graph docked in any place, and this may be also something what you may want, so that it does not give you a docking station if you don't want so. Okay, this is just a remark about the graphs in general. Also new is the report. We have a report editor which is updated. You cannot see it on the first glance, but of course it's our job to have software in the background updated. What is a nice functionality now is you can just zoom in and zoom out by pressing the control button when you use scrolling. So beside that, of course, there are some zoom options also available. You can see on the icon list. And so this is then a new functionality which the new report editor provides. Okay, so also in this new report editor, the graphs are in SVG format, what makes the report size very small. So that's it for the main features in handling, in general handling. Now I'd like to start with the features. And the first feature I would like to introduce to you is the new module for KISSdesign. As you can see, the KISSdesign is available from now. And what is actually KISSdesign? It is our new tool for systems. Let's say so, to be precise, we are working on this new system tool. We have now the sketcher functionality finished. So the sketcher functionality is available, and we will consequently then add all features what we have currently in KISSsys. We will also then implement in the new module KISSdesign. Just to make it clear today, KISSsys is our main tool for system calculation. So if you do any system calculation with load spectra, with the shaft and gears connected by Annex E, and so on, with vibrations, KISSsys is our tool, what we recommend you for system calculation. What we aim for the KISSdesign module is to have in modeling a more intuitive handling, an easier model setup, and a better user guidance. So you can see here we have a shaft view, we have an element box, we have a calculations view, and here in the main field we have the sketcher. So let's just start. I will now create a model, and the model I will do first with the element box. I click on a shaft calculation, I add a gear, I add two bearings, and add a coupling. So this is first shaft. If I want to do a second shaft, I just click on shaft calculation again. I again add a gear, two bearings, and a coupling. And already now you can see there is a structure implemented in KISSdesign what gives a higher safety in modeling, is a better guidance in modeling, and this is really comfortable because the software gives this structure in behind. So as next, I would like to add a gear pair ratio, and I can just now add the gears into the helical gear pair connection. So now we can also see that this is now connected. I can go to the kinematics. I can give a torque and speed, and so we have a torque, we have a speed, and I also will give a ratio now. You also can see I can define the ratio on several ways. I can define a gear number, a number of twos for gear A, for gear B. I can give a ratio instead. I can give quite many options how to define the ratio. In this case, I will just enter the number of the T's for gear A, gear B. This gives me a ratio, and this is directly now implemented into the kinematics. Also this handling shows that the way of defining kinematics is much easier in KISSdesign, and this was also our target. So, but now we want to model the same gearbox in the sketcher, and sketcher is a nice feature what you allows to have a concept finding. Is a graphical support for the user. I just first do now a shaft. I put an axis coaxial to the shaft. Then I put here a cylindrical gear. On this dot I put a bearing. I put a bearing again, and here I will have a connecting coupling. Second shaft, I do the same. By a double click I can create the shaft. I just put the axis coaxial to the shaft. Again, I have a cylindrical gear pair here. You can see it works by right mouse click. So it's now a bearing again, and now the output coupling. So what I can do now with the cylindrical gears, I can now drag and drop the connection, and you can see the software now does not let me to place this anywhere. It only allows me to place it on another gear, with what makes sense, absolutely. And so the user is guided by the software, and it gives him safety not to do any nonsense. Again, now then the rest of the kinematic would be the same. We already did it before. I just wanted to show you that the sketcher gives you a nice opportunity. What is also improved by KISSdesign instead to KISSsys for model building is the flexibility. Let's say at the moment we spontaneously decide to have here one more stage. I decide to have a bevel here at the end and not to have a coupling. Okay, I will have this bevel stage now here. I add a second shaft. This is a vertical one. I add a bevel stage, and again I will connect this by drag and drop. So I will add two bearings, and now the final output coupling is here. Okay, so we can see now all the connections, they are automatically done. Also, I want to show you the 3D viewer. I did not do this before, but the 3D viewer is always updating the physical parts which are currently defined by the user default geometry. And you can see also there are the boundaries, they are updated to the connections what I have. So this is the parts which are much more easy now with KISSdesign than with KISSsys. So again, I can define ratios. So, and the new gearbox as a draft looks like this. Okay, so besides this standard kinematics, also we want to provide, with KISSdesign, we want to provide kinematics for shifted transmissions. Let's do now a shifted transmission, and let's use for that the group modeling option. So at the moment we want to do a shifted transmission by a main shaft and a lay shaft. So there are two shafts. Then I want to have 5 speeds. And I want to have, of course, then also 5 loose gears. And now I will use this assistant by the KISSdesign, and you can see it modeled a proposal for a transmission. You can see these are the main gears, these are the loose gears which are activated by the coupling. And so now I can take care of the ratio. Let's have a look in 3D viewer. Okay, this is the current ratio. They all have the same ratio, the same gears, but let's do so now. Now we want to have different ratios, of course. So I will just enter here some numbers for different gears, and I just do it quite easy, quite logic with the system of having same sum of number of T's, so that the center distance will be the same for all of them as you will need to have also for shifted transmissions. Now my transmission looks like this. So, and as a next step, and if you know KISSsys, also as a next step, the shifting the speed table, we call it speed table in KISSsys, switching matrix, we need to define the couplings which are engaged or are disengaged in certain speeds. And in order to do that, we have a nice functionality in KISSdesign. We have a sizing functionality. I need to add first the power. I didn't do so far. I did not add any kinematics. I will do right now. So I just added here the couplings. I need to add coupling in order to define the kinematics. Now I have the two boundaries. I can define now torque and speed. So, and now at this time I can use the sizing functionality for the speed table. So, and now what the software does, you can see it says which gears are open, or which couplings actually are open and are closed in what speed. So in background, all the connections, all the possible connections for the kinematics are checked, and depending on the final speed, on the speed of each gear pair, it will create this speed table. This is a big help, of course. Also, if you then maybe decide, of course, your gears may not have all the same sequence. Typically, the speed 1, speed 2, it will be a different place, so you can rearrange your positions of the gears. I'll type it in again. So okay. So again, I'll do sizing, and you can use this functionality as often as you want. Of course, when you rearrange the speeds, you can also create a new speed table. So this is the first introduction on how shifted transmissions are modeled in KISSdesign. I can also see here when I click, this is also a nice thing in KISSdesign. If you click on a gear, you can see it highlighted in the 3D, but it's also highlighted in the shaft view. Of course, I can also change now different speeds. So also the power flow is highlighted in the 3D view, and this helps me to understand what the software currently has implemented. As a last sample, I would like to show you now. As a last sample, I will show you a double clutch transmission. So this is a prepared file, but the file was also created by the group modeling assistant. So, and here again we can see the benefit of the KISSdesign. We can see the power flow here directly, but again, if I see the gear number one is used for 2 speeds. Yeah, so, and we can find it also in our overviews directly. We can find gear 1 highlighted here and here, so it's easy to detect where each gear is used in what gear pair calculations. Okay, so this should just show you let's say the features of the KISSdesign. We will have an own web demo about KISSdesign, and there our programmers, they will show you directly more features, also planetary stage, how to model planetary stages with the shaft design, with hollow shaft designs as well. And there, of course, you can ask also very many detailed questions. As a last feature from KISSdesign, I would like to show you an import functionality of a drivetrain which is saved in the rex format. The rex format is an exchange file for drivetrains, which is introduced by some German companies. and it is established as a very common interface format now, and we also have it in KISSdesign, but also in KISSsys. So, and this was just a simple one stage gearbox, and you can see it was reading all these bearings. It was reading the shaft geometry, gears, connections, the kinematics was imported directly from the Rex file. So, of course, you may be also wondering about costs of this new module, the KISSdesign. We are happy to tell you that KISSdesign is for free for all KISSsys users except the sketcher functionality. So this is our strategy to have a successor then in future for KISSsys, and therefore KISSdesign will be free of charge for all KISSsys user, but the sketcher functionality is new and this is to be purchased. If you're interested, of course, you can contact us on any time. So now I will go on with the software features for the release 2019, and I will go to the shaft and bearing calculation. In the shaft and bearing calculation, there are also some from the handling side, some new features I would like to show you directly in a sample. We have here a sample file for truck transmission, and very obvious it is that now in the KISSsoft 2019 there is a 3D viewer. So it means the shaft and bearing, it can be also coaxial shaft systems. This is shown directly in a 3D view, and this helps you at the moment of creating a shaft and bearing system to understand what the software actually does. This is very comprehensive. Also, we added this toolbar here, and this is also very comfortable. For example, the functionality for moving forces and bearings. This you know already, but now we have a very quick access on this functionality. So it means now the moving of elements is activated. You can see that, but as long as we would like to have fixed positions, and if I deactivate the option, I cannot move anything by default, by mistake. Also, a nice functionality is to have the dimensioning. Now we have dimensioning of the full system, and we also added in the 2019 release, we added that if you want to check about an individual shaft, let's say here the input shaft, you would like to verify. So now also this input shaft shows now with the dimensions. This makes it very easy to check the dimensions of an individual shaft. And of course, we can go back now and display all shafts again. So one more nice feature is in the new release, for example, you would like to move this loose gear. And this is actually a shaft, but also the gear as a force itself. And now we can move this shaft, including the gear, the force elements, directly with this grip point. This is very nice, so we don't need to move individually shaft geometry and force elements by themselves. Okay, what we also, I will continue now with the bearing calculation and actually with the SKF Cloud. As you know, maybe from the last release, we already had the partnership with SKF announced, and this within this partnership now we added the calculation through the SKF Cloud also for the shaft calculation. And this means if you have the modified rating live according to ISO active, and if you have registered with the SKF registration tool as I did, so, and then you press calculate, then the connection to the SKF server will be created and the calculation is performed at the SKF server. We have some messages from this calculation. So, and then we can see in the result window, we can see the calculation with the SKF bearing module, but also the calculation according to ISO 281, which is the KISSsoft calculation, and the SKF bearing module is just shown to you as a service. So this is a nice cooperation what we currently have, and also one new feature is that we have now bearing data from SKF with inner geometry. We are very happy. We are very happy to have this in the new release, and this gives us the possibility to have a much better approximation of the inner geometry. I will tell you how it works. Let's say so we have here needle roller bearings, and if we would go to any size of it, let's go for a 20 millimeter diameter, and I will have a look at an SKF bearing. Then I can see here internal geometry. I can see the number of rollers, I can see diameter of rollers and rolling body pitch circle diameter. We do not have the effective roller length, and we do not have microgeometry. But with these three numbers, it's very precise to approximate the full inner geometry of the bearing. And I can just show you on contrary, if I have any other bearing, we don't have this information at all. So to be honest, also with this data, we were able to have a more precise approximation in general. So if you use the 2019 release, and you compare bearing inner geometry approximation between the previous and the current release, then you may find much improved approximation with the current release. Also, of course, we recommend always to have some tests done before you switch between the previous and the next release, just to be aware of any possible changes. Also, a nice functionality what we added in the shaft calculation is also regarding bearings. Let's say so the designer would like to replace this bearing what he has here. So, and this is the existing sizing functionality of KISSsoft to have a new rolling bearing with all the lifetimes. But new now is that we also have a column available for prices. This also lets you import and define prices on all rolling bearings. And then in this moment, you can decide not only of a best performance of a rolling bearing, but also on the best price. And the price you can actually quite nicely introduce into the database by yourself with an import of a list. If you have questions about that, please just contact us. Also, I am quite proud that at the KISSsoft user meeting in October, we have a presentation from SKF Netherlands, and also in the workshops we have experts here from SKF Netherlands, and they will in a workshop also tell us about all their secrets, I guess. Maybe not the secrets, but of course they will answer all your questions. So I'm quite quite close to end with my part of the new features. Before I end, I would like to go into the bevel gears, and bevel gears I would like to show you the newest features also. One feature actually is not even directly connected with calculation. It's the script editor. Script editor we implemented in KISSsoft 2019 now for all the modules. And the script editor allows you to have an automatization within KISSsoft. I guess you heard about the COM interface. The COM interface is also a tool for automatization, but from external software. If you're internally of KISSsoft, the script editor provides you an programming language, and I would like to show this right now to you. So there are several options what we can do, whether we can have it as a pre-calculation, post-calculation check. At the moment, I will use a I will use a pre-calculation check, and I just have a sample. So in that case, I would like to check, or I would like the software to do a check before any calculation is done. The check about profile shift coefficient, if it is bigger than 0.2, then it will give a message and it will set the profile shift to 0.2. At the moment, I can see it's 0.2307. So if I just say OK, and now I press calculate, now the message appears, what is expected, and it will also now change the value in the software. So this application of the scripting is very universal. You can do it from easy calculations as pre-calculations, post-calculations, up to complete sizings and loops and whatever you like. So if you have programming skills, feel free to use script editors to make automatizations. It's quite a powerful tool. So, and as a last point from my side about bevel gears, I just show you what we added in the bevel gear calculation. We implemented the interface to the GEMS software. The GEMS software is the bevel and hybrid gear software from Gleason Rochester, and this is the software for manufacturing on conventional machines. It means all machine settings, all tools are defined there. So if a designer, an engineer wants to design a bevel gear, he may start with a KISSsoft-Design. He will then export this KISSsoft-Design to GEMS. In GEMS, he will check about manufacturing feasibility, and back he can then import into from GEMS into KISSsoft again. So now still this calculation was active. I just do it without that calculation. So, and now I have the same data set from Gleason software now imported into KISSsoft, and in both software there is a consistent calculation, and I have the chance now to do a rating of all the ISO calculations, HMI, DIN calculations, and so on. Also, as a last one, the flank fracture calculation is very new from the ISO committee, and we implemented a draft already. So if you have the case of flank fracture on your bevel and hybrid gears, you can use the draft in KISSsoft and you can do a rating for flank fracture. Okay, that's from my side, and now I will forward to my colleague, to Ilya Zikur. Thank you.
Oh, hello from my side as well. Thank you, Jörg, for this nice presentation. So I would like to tell you about the new features within the gear design or gears in general. We have some major new things that I will show you, but also some smaller further developments that we have done. I would like to start also with some general stuff. You can see that here in the user interface, we have changed the final machining tab to a new tab, which is now called manufacturing. So the idea behind that was that we consolidate all the manufacturing related parameters into this one tab, where you can then basically define your pre-machining. Are you hobbing the gears, or do you use a pinion type cutter? And about final machining, do you grind the gears, or do you have maybe some data available for a worm grinder and a dressing wheel, and so on. So these things are now found right over here. And for example, you can see here on the right side, we can see basically the grinding notch, and we also see how deep we grind. These parameters can also be controlled right away in this tab. Also, how deep do you grind, and so on. Okay, another interesting thing that we have added, if you do gear manufacturing, for some specific cases, you cannot use a hobbing type cutter to cut a pinion gear. I will show you an example. I have here a KISS's model, and this process is called Power Skiving. This is a special method to manufacture gears. This technology is also provided by Gleason, and you can see the problem here is that we have a pinion which we have to manufacture. This would be the tool for manufacturing. And because of this shoulder that we have here on the shaft, we would not be able to use a hobbing cutter, or nor even maybe a grinding wheel or a grinding worm to actually manufacture the gear. And in this particular case, also for internal gears, I will not show this now, this process, power skiving, is important. And what we now do in KISSsoft is that we do a feasibility assessment or a feasibility check if for a certain configuration, you can use power skiving as manufacturing method. This is what we have added here. You can see in KISSsoft, we have now a check for power skiving. So I can hit on the plus button, and now I can either select the machine by Gleason. So this machine's Gleason 100 PS or 300 PS. PS stands for power skiving. But if you're using another manufacturer, so not Gleason per se, you can also change to own input and then define the minimum and maximum tool diameters on your own. Another interesting feature is that you can actually size the number of teeth for the tool for power skiving, and this is done then automatically by the software. Of course, you can also change the cross-axis angle. This would basically be this angle of the tool while you manufacture the gear, and you can test different arrangements. Now, another important feature is the collision check, which I've already addressed before. Let's do a collision check for gear 1. And here you can see we need to enter the groove width and groove diameter. I'll just hit the info button so you see what I mean. So we have here the groove width, and we have here the groove diameter, and this blue thing would be my tool. So what the software is going to check is basically if you may expect some collisions due to manufacturing or during manufacturing. So I will close this, hit the OK button, and just run the calculation. I get a warning that if I grind the gears, I should also check the 2D graphics, but I will not do that right now. I just hit OK and go to the general report. Jörg Langhart already showed you the new features within the report, so I will not address them. I'll just make it a bit bigger and scroll down in the report, and we have here a special field for manufacturing, which is new. Now you can see here for manufacturing, we do power skiving, and we get the result that probably it's possible for this arrangement. There is a very low probability of tool collision, and so on. Yeah, and here you can basically see also all the relevant process parameters for power skiving. So this is quite a new feature, quite a nice feature. In addition, we have added the same feature for fine sizing. If I just open now cylindrical gears example number 1, I go again back to the manufacturing tab and enter here some shoulders. So let's say again, I'll use a groove width of maybe 20 and a groove diameter of maybe 60 millimeters, hit the OK button. Now I can go for the fine sizing and oh, this is rough sizing. I go for the fine sizing, of course, and now I can just set here the module range as you know it, maybe from 5.5 to 6 in a step size of 0.5. And I'll also eliminate all solutions that have a lower requested safety factor. Hit the calculate button. And what we have added additionally is that already in the fine sizing table, what you see right here, you will get results for power skiving. And as you know, for the gear 1, I've added a check for collision. So it says it is power skivable, so yes. And for the gear number 2, I didn't enter any data, so it wasn't checked. And here in this list, you get also the suggested number of teeth for the tool for power skiving. Well, clearly, power skiving is not a process that you would see very often, but it gets more and more popular now in the industry. We are maybe also in future, we're going to do the same procedure for honing, but this is still under development. Okay, so I'll move on to the next topic, and the next topic is asymmetric gears. So I'll just open an example of an asymmetric tooling. So let me just show you how it looks like. I will change here a bit these graphics and use just a normal transverse section. So here you can see how such an asymmetric gear looks like. As you know, if you design asymmetric teeth well, if they're well designed, you can actually gain some torque capacity in the gearbox for the same gearbox size. So in KISSsoft, it is possible to calculate now asymmetric gears just by going to the module specific settings and activating this checkbox for asymmetric teeth. And this allows you to enter now the pressure angle left and right, which we see here on the left side, we have a lower pressure angle, and on the right side, we have a higher pressure angle. Because of this, we also hope to get decreased Hertz stresses, so also more torque capacity of the gearbox. And in the reference profile, we have now also the reference profile of each tooth left and right. Okay. A new feature we added is the sizing of root radius coefficients for such an asymmetric tooling. So I could say I would like to use, let's say, 1-to-1 ratio. That would give me same root radius coefficients, same values, but maximum possible values. Or I could divide this ratio. Let's say I would use a factor of 1.2, and that way I have a smaller radius on the left and a bigger radius on the right. So this is quite a nice feature. What's completely new is that we have adapted our contact analysis model. So maybe you've heard about Weber and Banaszek model. We have adapted this to asymmetric teeth, and that means that we are now able to calculate the single tooth stiffness and the complete meshing stiffness based on asymmetric tooth profiles, which is quite nice. So for all of you who wish to perform gear optimization, optimize them in terms of vibration, excitation, noise, efficiency, and so on. So if you have asymmetric teeth, it's now possible with KISSsoft. So I'll just hit the calculate button, and we can basically have a look now at the contact analysis results of such an asymmetric meshing. You could also now design modifications and whatever you wish to do. Here you can also see the full results of the contact analysis, like transmission error, stiffness, torque, power losses, efficiency, and so on. Okay. I'll go straight forward to the next topic. This is actually the new features within the contact analysis module itself. So I just open now a symmetric meshing, so symmetric tooling. So the first thing you're going to see in contact analysis is that we have added the runout error. So the runout error basically allows you to also consider certain manufacturing constraints or manufacturing errors within the contact analysis module. So basically what it does, it's going to also consider some shifts within the center distance range because of the runout error. So if I perform now the contact analysis, you will see that we have actually sorted a bit the graphics and the results of contact analysis. So if I go now to graphics, contact analysis, you see that we have now grouped the results into certain categories. For example, here you will see all the relevant stuff in terms of excitation, like force excitation or transmission error, all the possible amplitude spectrums, and so on. Efficiency, here you get the temperatures, power losses, we have forces and stresses, and the safeties. What is actually quite new is that we have added a graphic to cylindrical gears to show you the contact pattern. This is something we didn't have before. We had it for bevel gears, but now we also introduced it to cylindrical gears. So you could basically simulate that as well. Another nice feature is that we have added the graphic for tooth root stresses in 2D and 3D. And the nice thing is that we can now show you, on one hand, the tooth root stresses based on contact analysis at this 30 degrees tangent, which is coming from the ISO or DIN standard calculations. And we could compare it with the stresses that result from the graphical method calculation. The graphical method would basically find the critical section at the root area based on the tooth geometry, actually. Okay, so that's also quite a nice feature. And what we have as well is we have now the tooth root stresses along the face width. So here you can see bending stress in the root area. And what I'm actually looking for is the root stresses along the face width. Let me see if I can find it. Yeah, contact lines. We have right here tooth root stresses. This I already shown. We also have a graphic where we can actually show it along the entire face width. This is the graphic I was looking for. And here you can actually see that we divide the gear into a certain amount of sections. And here you would basically see along the face width, what would you expect to have as root stresses, again, at the 30 degrees tangent, or based on the graphical method. So these are the new features within the contact analysis tool. Heading over for the next topic, we can now in KISSsoft calculate a double pinion planetary set. Let me maybe explain it shortly what it is. This is quite a common in automotive applications. So how you can imagine is that it is in a 4-gear chain module, and you can actually see it. It's not a planetary gear calculation. It's within the 4-gear chain module. So what can be is that your gear 4 is an internal gear. So let me press calculate. And if gear 4 is an internal gear, then you may as well consider a planetary arrangement of such a system, and this would look like that. So you can see here we have the center, the sun gear, and we have 2 planets, and this is why this configuration is called double pinion planetary set. And we can perform not only the calculation of such a system, but we can also include this into gear sizing. So gear fine sizing, if I would just go over here, then I can say that I would like to perform the fine sizing as double planetary stage, where I could set the gear ratio from Z3 to Z2. These are the gears, third gear and gear number 2. And that way, KISSsoft would also vary these different center distances between, so this center distance and that center distance. And then you can find basically an optimal solution for such a problem. In addition, if you use such a double planetary arrangement, you can go and enter here with the plus button the speed of the carrier. So I'm going to repeat something I said before. This planetary arrangement is now in KISSsoft done within the 4-gear chain module. So that's important to know. Okay. Going on to the next topic, I would like to show you the modification sizing. So quite a nice feature that we have added to contact analysis, and for all of you who use this modification sizing module, is that we now can include a load spectrum into the calculation directly. So if I go to the rating tab, you can see I have defined here myself a load spectrum. We have here a frequency of 20%, 55%, and 25%. And for this low frequency, we have 20% more power that goes into the system. Then we have here the nominal power, which is scaled by this 75 kilowatts, of course. And for a certain period of time, we have 65% of total power. So this is an example load cycle. Now, if I would size a modification, first I would size a profile modification, let's say for the nominal load. You can see here, I have a tip relief and a root relief for gear 1. So basically, I'm only grinding the pinion. And I have here a modification value of about 45 microns. And this modification is optimal only for the load range right here. So it would be for my nominal load. So how can I evaluate or how can I test my modifications for the entire load spectrum? And this is now what we have added to modification sizing. So now instead of entering the partial load on your own, you can just say, I want to consider the load spectrum directly. And now I could basically go to condition number 2, load my modifications and enter here some kind of a step size, let's say maybe 2, and I'll vary the tip relief and root relief values from, let's say, 40 microns up to 55 microns, which is right here. Just press calculate, and now we will need to run 15 times the contact analysis. And well, before you really had to set the range for the load on your own, and now the modification sizing module takes your load spectrum and uses only the bins with the load that you have specified. And this, of course, gives you a huge advantage when you're looking for a compromise when you size profile modifications for the entire load range. So this is what the software does now. We just wait a bit till the calculation finishes. Takes also some time to generate the graphics. And then we will have a look at the results. We have, by the way, included to the web demonstration, you will find in the upper right corner below, you will find some material as PDF that we have provided. So you can download the full changes document in English to see what changes have been made from release 2018 up to release 2019. Okay, so now we get some results, and you can see that the load is exactly taken from my load spectrum. So if I go now to my so-called spider web diagrams, so what does it depict? You will see that there are some different solutions. Solution number 0 is the solution without modifications. Solution number 1, 2, 3, or 4 are different combination of tip and root relief values, which I was changing. And this is shown for all partial loads. I had in my load spectrum here 3 partial loads, and they're depicted right here. And that way I can find quite easily that the best compromise for the entire load spectrum would be this solution, because you can see all of these relative peak-to-peak transmission errors are the lowest, right? So that way I found out that the solution number 2, sorry, it was not number 3, solution number 2 is the global optimum for my optimization problem. So now I can go back to my results, take the solution number 2. So it will now be taken directly into the interface, and you can see that the best values would be then a combination of a tip relief with 40 microns combined with a root relief of 45 microns. So this is quite a nice feature. And last but not least, I would like to show you the crossed helical gear rack, which is also a new feature in KISSsoft. This is found in examples crossed helical gears. There's an example of a crossed helical gear pair with a gear rack. So where is this being used? Well, if you do some steering mechanisms for cars, it may be that you find these kind of teething or toothings applied. And this is now also possible in KISSsoft. Let me first show you how this looks like. So I press calculate, and I will go now to the 3D graphics. And this is now just a surface model. Of course, you can also make a full body model, but you can see basically the arrangement. So now if I don't have a play button here, we don't have that for racks, but you can see here basically what is happening. So there's a cross-axis angle, and we can now basically simulate this steering process based on a crossed helical gear, which you can see here, and a gear rack, which has here a helix angle, but it can also be a spur gear. It would also be possible. What the software does in the background, it basically sets the number of teeth of the counter gear, gear 2, to infinity. And in the tab details, you can set the cross-axis angle for such a configuration and define the rack length for your application. That way, you will also be able to perform geometry analysis, but also the safety analysis for root and flank safety, as you know it from the crossed helical gears. So with this, I did come to an end of my presentation. Me and Jörg, we really hope you liked it. These are the new features, and as Jörg already mentioned, you can download the new release from now on from the customer area if you have a maintenance contract with us. But if you don't have one, just contact your corresponding reseller or contact us directly if you wish to ask for an offer, and we can offer you the update of your license to the current release. In addition, I would also like to highlight or invite you personally to the KISSsoft user meeting. By the way, this year, the user meeting is done in English, so you will also understand what is said. Normally, it's done in German, and it's going to take place 23rd to 24th of October. So feel free to subscribe, visit us, see our office, and touch the new features yourself together with us. Thank you very much for your attention. We all wish you a very nice day. Goodbye.